Awesome. Welcome, everybody, to the March edition of the OpenXLA community meeting. We have a really jam-packed agenda, so we're going to go ahead and get started right away. Let's start with introductions. We want to welcome any new attendees. What would be great is if you could just quickly introduce yourself, about 30 seconds, what company you work for, and what are you looking to focus on. Elliot, would you like to go first?
Sure. So, hi everyone. I'm Elliot. I'm the new TL for OpenXLA here at Google, and I will be sort of taking, care of a lot of the technical sort of direction decisions, or at least helping the community and some of the internal discussions here to come to consensus and organize a roadmap and help really smooth the community process on our side, because we know that there's a lot of things that we have to work on to accelerate developer productivity and our ability to get new features out. So yeah, we'll be investing on that.
Perfect. Thank you so much. Anyone else? All right. Going, gone. Awesome. So just a quick reminder of what is OpenXLA. It is an open state-of-the-art ML compiler ecosystem, and it's built collaboratively with all of our partners. That's the ultimate. Let's go ahead and get started with the agenda. Aman, I'm going to turn it over to you to talk about the PGRT blog post that was published a few weeks ago.
All right. Thanks, Aditi. Yes. So good morning, everyone. We recently announced or launched a blog post which covers a few things. One is, what is a PGRT plugin? What does building a PGRT plugin entail? How frameworks may discover the PGRT plugin to launch the right plugin for your hardware. The blog also has updates on the PGRT API, specifically around versioning and API compatibility, support for multi-node, DLpack, etc. Beyond these PGRT updates, we also had shared a spotlight on Apple's adoption of PGRT to support Apple Silicon. How stable HL is generated, the compile and execute method is called, MPS graphs are generated for the Apple Silicon, and then that's all of that is packaged into a metal plugin. So some details regarding that are also on the blog post. And with Apple's adoption of PGRT now, PGRT is being used by a spectrum or a range of hardware targets. When we had announced PGRT early last spring, almost a year ago, after that, we had great collaboration with Intel, which led to a joint blog post with Intel, where PGRT is now used for Intel Max GPU. Then going forward, obviously, PGRT was also used to enable Google Cloud GPUs. And we also had support for NVIDIA GPUs, both of which we talked about in the OpenXLA developer meeting last fall. And this time now we are talking publicly how Apple has adopted PGRT to run JAX on their hardware. So please feel free to take a look at the blog post. Reach out to us with any comments, questions that you may have. And obviously, we look forward to working with even more of you to not only enable, if you want to run JAX on your hardware, we'd love to work with you. And if you want to converge the support for the various frameworks for your hardware, we'd also love to work with you on that.
Perfect. Thank you so much, Aman. And just kind of a announcement to the community, if anyone has any success stories that you want to share, please reach out and we can figure out how to put a blog post together as well, just so that we are successfully highlighting our success stories and letting the world know about this open source ecosystem that we've got in play. Perfect. So let's go ahead and get to the technical updates. Jae-sung, I'm going to turn it over to you to talk about the stable HLO quantizer.
Yeah, thanks. I'm Jae-sung. I have worked on the model optimization project at Google. Today, I will introduce our stable HLO quantizer project. I would like to get today I would like to get early feedback on it, from the community and also want to check whether there are any interest in using it, and are there any future collaboration opportunity on this project from the community. Before talking this, I briefly give a overview of this project in this forum. Um, this is kind of our motivation. As an algorithm developer for model optimization technique, achieving algorithm scalability is really hard problem. In many cases, algorithm implementation usually bound to either certain hardware or specific machine learning framework. In that way, it might be better to achieve the optimal solution for certain hardware or specific framework. However, algorithm developer like us will need to develop same algorithm here and there and again and again. As we know that there are multiple machine learning framework are available in the world, for example, PyTorch, JAX, and TensorFlow, and so on. This scalability issues becomes a real problem to us. We can imagine that these situations get worse as many great machine learning accelerators have appeared in the industry, and new algorithm techniques are being immersed for the GenAI model and many new type of the ML tasks as well. Next slide, please. Yeah, thanks. So to solve this scalability problem, we kind of made this is kind of our vision of our project. As I said, currently many existing contagion solutions are bound either framework or hardware. This situation makes us whenever there is a new hardware pop up or new amazing framework appear, we need to rewrite the same algorithm implementation again and again. This is a big burden. So to overcome that, in this new contagion, align with the nature of the stable HL languages, we would like to increase the usability of the algorithm implementation. For instance, write algorithm once and run everywhere in ML domain will be the main motivation of this project. Next slide. This captures the internal details of the stable HL quantizer. Currently, we have a very early version of the stable HL quantizer implementation, and this implementation is currently part of the cloud inference converter for XLA runtime, and especially for server and desktop environments. And we also, for the mobile story, we have enabled this quantizer within DevLab product as an alpha version. In short, basically the same algorithm implementation can be used for mobile and server both through these ongoing integration and development. To achieve that, we use a stable HL graph as the main source of the quantization process, and we actively leverage a uniform quantization representation that is available in stable HL languages that actually help explicitly express ML hardware execution, especially for quantization execution, and we build a hardware downstream lawyering passes actively, especially for XLA runtime and the DevLab product story. Next slide, please. Yeah, this is a kind of quick overview of the stable quantizer. I would like to get some feedback for this project, and we also welcome any question. Also, if you're some of you might interest in using it in the future, or also interested in the future collaboration, feel free to let us know. Yeah, if we have enough interest in the community, we would like to accelerate open sourcing it through the OpenXLA ecosystem in the future. And another motivation why we are open sourcing it is that as a model optimization developer, we hope that we would like to enhance overall quantization execution ecosystem through this open sourcing opportunity.
Perfect. Are there any questions? Let's just open the floor up. Is there any interest in using this collaborations?
I just have one question. This is Mahmoud. So I joined late, sorry, so I'm not sure if you already covered that. So if the user has like a TF TensorFlow save model to start with, and then uses the stability or quantizer, is it possible to quantize the model and using stability or quantizer and then save it back again in some format like save model, but keep the structure, the signature, everything the same, the input and output of the model? So mainly if the user has some data processing layer before the actual model, so he can maintain that as well.
That is a really good question. Can you go back one slide back? Thank you. So this picture actually captured we actually have we would like to cover two scenarios in the long term. Right now, what we have is offline quantization, and you can see that we have some serialization format in the offline quantization scenario. For example, for XLA runtime side, we utilize save model format that actually contains the state ratio graph as a artifacts. So yeah, this offline quantizer actually takes save model and produce quantized save model, and the quantized save model actually have the save ratio based quantizer execution. That is one way, and TF-Lite also have a similar story, but serialization format is bound to the TF-Lite product and their serialization format proper. That is for the offline quantization, and we also are willing to build us some new story with the online quantization. We would like to integrate these quantization passes, mostly written in the MLIR. We would like to deploy them on the various compiler and the ML compiler at integration. We would like to. We don't worry about the serialization format. We can actually enable quantization on the fly. That is also we would like to enable in the future. I hope that this question answered the question.
So TF-Lite in this path, like, is it optional right now, or you have to go through TF-Lite using this flow?
Yeah, to use this flow for the ODML, you can use this flow with a TF-Lite API. Actually, we already launched initial version into the TF-Lite product that is available, and also inference compiler has a we also expose this API through the inference compiler as well for the save model based story. So yeah, yeah, user can utilize these products to apply the quantization through the disk quantization. That is kind of, still kind of experimental mode, but it is kind of available right now.
Okay, thank you.
Perfect. Thank you, Mahmoud, for your question. And thank you, Jason, for your presentation. Please do reach out, folks, with any questions that you may have. All right. So in the interest of time, we're going to keep moving. Andy, I'm going to turn it over to you and your team to talk about the Chardonnay RFC.
Yeah, I think Andy can't actually make the meeting, so it's just myself and Tom here.
Perfect.
Let me go through the slides. Cool. So Chardonnay is a new partitioner that we've been working on, and so it's a collaboration between the team behind GSBMD, which is the partitioner in XLA developed by Google's XLA team, and PartIR, which is an MLIR-based partitioner developed here in London by DeepMind. If you Google for it, you should find there's published a bunch of papers and things. So the idea here is really to bring the best of those two projects together in terms of features. Like, for example, in PartIR, we had priorities, which give users a lot of control over how their shardings are propagated. So very minimal sharding annotations, you can get the partitioning that you want. And from GSBMD, things like the intermediate sharding annotations, which give you a lot of control over how intermediates in your computation are sharded, but also bringing together two teams that have kind of years worth of experience working in this space, and targeting both sort of research and production use cases. One of our explicit goals is to improve user control, like I mentioned, things like priorities, but also debuggability, so make it easy to understand what's happening in the partitioner. So this project is developed in MLIR, and it will be open source as part of OpenXLA, so it's an MLIR, which makes it kind of compatible with with OpenXLA, what a lot of you guys are doing, but also makes it easier to build other compiler infrastructure around it. And yeah, we're curious to kind of hear your feedback. Next slide, please. So this is just a quick overview. Today, what we're working on is the sharding propagation aspect of partitioning. So we're essentially replacing the GSBMD propagation pass, but we're still, for now, relying on the GSBMD partitioner, which is the compiler pass that actually takes the sharding annotations and turns the ops into kind of local ops, introduces the communication collectors and things like that. So we're focusing on the propagation part, which is kind of the most sort of user-facing part and what users care about the most. But in future, we'll also want to replace the actual partitioning logic with a new pass in MLIR, so that we have an end-to-end MLIR partitioning setup. The way we currently implement that is behind a flag, which allows you to try out the new partitioner, although this is not yet open source. Yeah, there's a question.
I didn't mean to interject. I mean, I can ask the question at the end if that's okay.
It's up to you. Yeah, I don't mind.
Okay. So this means that there's a round trip from HLO to PartIR dialect and then back to HLOs.
Yeah, not PartIR. Yeah, Chardonnay dialect. Yeah. There is this round trip. That's, I guess, what this import-export here is also partially referring to, is this MHLO, HLO, MHLO round trip.
Okay. The other question that I have is there a specific advantage to doing this, or does it add any more functionality than the old pipeline? Because I mean, what's the main reason for doing this other than integrating this through MLIR, which makes it more general? I agree.
Yeah, good question. I would say it's twofold. One is sort of from a code complexity point of view, where both PartIR and GSBMD have kind of developed organically over the years, and this was kind of an opportunity to sort of reset and really just take the best ideas and make it very compact, simple code base. but also from a usability point of view, we want to look at things like, we're introducing things like priorities, which doesn't exist in gSplimD today, which gives users more control. We want to look at things like debuggability, but also new features, which I don't know if we're going to touch on it in the slides, but like, for example, reshapes are like a common a common point where today's partitioners, at least gSplimD and Padaya, both struggle to kind of handle things very well, reshapes in the most general sense. So we have some ideas on how to improve that situation. So there will be kind of new functionality which makes it more user friendly.
Okay. Yeah.
Cool. I'm going to hand over to Tom now, who's going to talk about some of the details of the dialect and what we have so far.
Yeah. Next slide, please. Yeah, so I'm going to talk about the different components of our API. I'm going to start with the sharding representation, which is the most important one. So again, this is MLIR, so we're using attributes. So first we have a mesh, which is a multi-dimensional view of the devices. So you can see below in the example, we have named axes with sizes. This defines the mesh. And then we have the sharding annotation, which is bound to a specific logical mesh by name, which allows us to have multiple views of the same set of devices if we need to. And then the core of the sharding representation is defining along which axis each dimension is sharded. So you can see that the first tensor dimension is sharded along W and then X. So it's major to minor. The second dimension is not sharded at all. Next slide, please. Oh, and like the tensor is replicated along all other axes. And then we have additional features. So dimensions can either be open or closed. Open, as you can see below, this question mark means that it can be further sharded. So the first tensor dimension is closed. It doesn't have the question mark, but you can have it be sharded but still open. So you don't see that here, but if the first dimension was open, you would see W, comma, X, comma, question mark. And then you can also constrain axes. So as we said in the previous slide, Y and Z are replicated, but we can mark Y as explicitly replicated, meaning that propagation can't use Y to shard the open dimensions. It's a guarantee that it will remain replicated. Next slide, please. Another concept that we have is axis splitting. So the user defines a mesh with axes of a certain size, but sometimes, as you can see in the motivating example, the axis is too big. We need to use a piece of it. So in this reshape example, the first reshape requires X to be split into two sub-axes. And as you can see, we have a way of referencing a specific piece of the axis with two numbers, which is basically defining how you reshape the axis and use one of the dimensions. And then you have another reshape that requires one of the sub-axes to be further split. So now you have three sub-axes, and note how the second sub-axis, the 4-2, remains the same. Next slide, please. And as Dom mentioned, we also have the concept of priorities to enable sort of incrementality. For example, you want to perhaps do batch parallelism first, then Megatron, then Zero, because Zero and batch operate along the same axis, so you don't want them to interfere, and you want batch parallelism to have a higher priority. So we allow attaching a priority to dimensions, which basically means that it defines an order in which those dimension shardings are taken into account and propagated. So the first iteration, Y will propagate and X and Z will kind of be ignored, then X in the next iteration, and then Z. But that doesn't mean that those can be overridden. Next slide, please. And now the other thing is how you attach shardings to inputs and outputs. So because we're in MLIR, we can attach those sharding attributes to function inputs and function outputs. Next slide, please. And for intermediates, which is similar to how JAX has with sharding constraints, we have a sharding constraint op. That all it does, it's an identity op that you pass through a value and that attaches a sharding to it. Next slide, please. The other API piece we have is shard as, shard like, which is a way of telling the compiler that we want two values that don't necessarily have data dependencies to be sharded in the same way. And how it works is we would have, if you go to, this is how this would be defined in JAX. And if you go to the next slide, you would see in MLAR, we have another op, which is called sharding group, which assigns a group ID to a value. And here you can see that arg0 and SSA value 1 have the same group ID. That's why they're going to be sharded in the same way. We have two types, as and like. As is stronger. We want them to have exactly the same sharding, whereas like is we want, if possible, we want them to kind of propagate between them, but if some other sharding reaches one of them, that's fine. They don't have to have exactly the same sharding. Next slide, please. Finally, we have manual computation, which is a way to allow users to define a subcomputation that they want to have its own sharding along certain axes. So here they mark model as an axis that they add the collectives to. So we would not, inside this block, we wouldn't propagate, we wouldn't touch the model axis because it's already operating on local tensors. If you go to the next slide, please. So this is how it would look like in our dialect. So it's a region-based op. It defines input and output shardings with the same sharding representation. And it defines manual axes. So those are axes that define how the body is local with respect to which axes. So it has local shapes with respect to model, but the other axis, which is the data axis, remains 3, which means that we can still propagate through this body, even though it's local, but with respect to another axis. Next slide, please. Yeah, that's it on Chardonnay. We would love any kind of feedback, and are there any questions? Yeah.
Hello, hi, I'm Buyan. So I don't know if you're aware, but me and one other collaborator have been working on a mesh dialect in upstream MLAR, but it's kind of undermanned, the project. So it hasn't progressed a lot recently, especially. So I was like curious if you wanna like collaborate on this, like somehow to join forces to develop something, because it's very similar what you're doing. I mean, it's always based on the GSPMD paper, I guess. So I'll be curious to know what's your stand on this. And basically to make it extendable, so we actually kind of don't even depend on stable HLO if possible. I mean, I know probably you use the stable HLO collectives at least, but yeah, that's.
Yeah, maybe actually let's start with the second point. So stable HLO. So we're building Chardonnay in a way that would be dialect agnostic. So yeah, we work with stable HLO, but we want it to only be something that's configurable. So we have some concept of a registry, also using MLAR attributes that allows you to tell us how to propagate through ops. So we're working with stable HLO, but any other dialect can define their own rules that would tell us how to propagate through their ops. That said, it's only propagation. So as long as GSPMD does partitioning, then it would be with HLO. But when we move lowering or the partitioner to Chardonnay, then we'll be able to, at least we want to do that as well. And
yeah, but would you want to have, like in Chardonnay, kind of replicate the collective operations, or you're gonna target right away tests, like immediately when you do the SPMD partitioning, you will generate stable HLO collectives?
That's a good question. So I think we'd be interested in having collectives that operate on axes, because they're easy to optimize and also for debuggability.
Just to mention, that's what I did in the mesh dialect upstream. It has collectives operations, so they have mesh semantics.
Yeah, those are great. We had that in part IR.
Yeah.
Yeah, I mean, it's probably a bit kind of beyond the scope of this meeting, but we should probably have a separate thing to talk about that.
Yeah, that would be great to connect further if you are interested in collaborating.
Yeah, and we should then also make sure that Andy is there, who's kind of on the Google's XLA side. Yeah.
Okay. So if you can post, like in the chat, your I mean, some way to contact you, that would be great.
Yep.
Thank you.
Great. Is there any other question?
Okay. Thank you, Boyan, for your question and your comment. And I have taken the AI that we need to follow up with you after this call. And then thanks to the Google DeepMind team for the presentation. All right, we're doing great on time. We're actually exactly where we need to be. So let's move forward with the next topic. Tom?
Yeah. Cool. So if you can go to the next slide, please. I'm going to talk about a proposal to add batch dimensions to gather and scatter. It's related to Chardonnay, and I'll explain how. And I added a link to the RFC that I posted on the previous slide. So the motivation is threefold. So batching should be conceptually simple. It's basically vectorizing over a dimension across all the tensors in operation, but sometimes it requires a lot of complex computation, and gather scatter is a great example of that, and I'll show you in the next slides. And also partitioners should be able to trivially partition batch dimensions without complicated pattern matching, which is usually the case when batching isn't expressed properly in those operations. And also the proposal will specifically make gather and scatter more expressive, which would make them easier to use by different frontends. Next slide, please. Yeah, so I'm going to start with a simple example, and I'm using JAX, but it's not. The proposal is for stable HLO and can be used by JAX and other frontends. So I'm using a dynamic slice to get a stable HLO dynamic slice in MLIR. Next slide, please. And now I want to add a batch dimension to the dynamic slice. So you see I use JAX VMAP to do that, and I want the batch dimension to be across both inputs of the dynamic slice. And what I'm getting is a gather, which is fine, but the gather doesn't really preserve the information about the batch dimensions. So you can see I added, like I marked those dimensions in blue, but there's no real concept of batch dimensions in gather, and that's why the IOTA is introduced to mimic batch dimension, but there's no real batch dimension in the starting dices. It's just concatenate, the IOTA is concatenated to allow this to happen. But again, we lose the information, which is not great. In general, it's not great for practitioners that want to identify those batch dimensions quickly. Next slide, please. And here I show how when you add sharding, so let's say I want to just shard this batch dimension of size 16 on axis X, and in MLIR I'm getting an MHLO sharding, but I want to be trivially, I wanted to trivially propagate this sharding from arg0 to the starting dices and to the result of the gather, because it's the same dimension. They need to be sharded in the same way. But I can't do this without pattern matching, seeing what this, how the starting dices are produced. And the conclusion is that stable HLO gather and scatter, which is similar, are not expressive enough. Next slide, please. And here's the inspiration for the proposal. So .general, on the other hand, has this concept of batch dimension. So on the top, I have a simple .general with no batching dimensions, and then I vmap that to add batch dimensions, and you can see that we get the same .general, just with those extra batch dimensions across both left-hand side and right-hand side. So the information is preserved and it's trivially partitionable because it's easy to identify where those batch dimensions are. Next slide, please. So the solution is to apply the same thing to gather scatter. So similar to how we have left-hand side, right-hand side batching DIMs in .general, we would have operand and starting dices batching DIMs in gather. So then when you vmap the dynamic slice, you would get this batching dimension explicit in the gather, and the information is preserved. And instead of, you don't have the IOTA anymore, and you can see that the index vector dim has, or one sec. No, so it's of size 2. I have a mistake there, but it's smaller because you no longer need the starting dices to index into the batch dimension. Instead, it's part of the starting dices batch dimensions that is specified there. Next slide, please. Yeah, that's it on the proposal. Any questions?
Just a general question on timelines for Chardonnay partitioner. Is there work to do any benchmarking and eventually turn it on by default? Is that the plan?
Yeah, eventually, yes. There's no concrete timeline at the moment. We've done some internal initial benchmarking, which is looking good, but at the same time, there's definitely more work to be done before that's going to switch. So yeah, no concrete timelines at the moment.
Okay, thanks.
Any other questions?
You mentioned there is more work to be done, right? Like, just curious, what are the big pending items?
So for Chardonnay.
Yes, for sure.
Yeah, so we're in the process of testing our initial implementation, and also we have the basic propagation in with some of this like conflict resolution, but not all of the conflict resolution strategies that GSPMD has. So we would need to find good ways to add that based on use cases that we have. So I think that's what we're going to spend time on next. Then we'll work on user migration, and like you said, we want to end up in a place where we can turn this on by default. And once that's done, then we'll look for for moving the partitioner itself, or at least parts of it. So it could be done incrementally, so that we make some of the partitioning decisions in Chardonnay, then defer to GSPMD, and then take more and more until the entire partitioner is in Chardonnay. But like Dom said, we don't have a clear timeline for that.
Got it. Yeah. Thank you.
Thank you, Jeff, for your question. All right, any other questions?
And if there's no question, I'm wondering how people think about this, like scatter gather. So I think this is a great addition, but in a way it all makes it complex, all even more complex. Like, would it actually make sense to simplify some of the aspects of scatter gather? Like it does, it's like at the moment it does a lot of things. It like does transposes and all sorts of things. Like you could easily break them into smaller operations. And I wonder if people have any opinions on that. Maybe not.
Yeah, I guess my take is that, Gather is really complex, and every time I'm going back to it, I need to, like, relearn it. But I don't think the adding batch dimensions makes it more complex in the sense that it has more attributes. But I think it's kind of like standalone attributes, which is nice. And then we need to have a separate discussions on, like Dom said, on whether we want to simplify it in another way. But adding those batch dimensions would be really helpful, I think in general, but also for us working on Chardonnay to easily propagate through batch dimensions, because we have a lot of use cases that hit that.
I think there are only a few people in the world who understand how gather scatter works. So I don't
That's
think
only
that
a temporary
make it
understanding.
worse. Yeah, I don't think you're gonna make it much worse.
Any other questions or comments, feedback? Awesome. Thank you to the Google DeepMind team.
There's an appendix with the actual changes, but you can also just look at the RFC.
Perfect. All right, PR velocity. Some of the community asks and challenges. Elliot.
Cool. So I guess we've heard a lot of feedback from the community that it's getting harder and harder to actually get PRs merged. And we wanted to speak about this a little bit and just start the process of how do we actually go improving the situation. I think the first thing to acknowledge from our side is that we've seen a tremendous growth in the number of contributions to OpenXLA. And this is fantastic. This means that, we're really seeing a community starting to form around the project. And it's not just like one particular contributor, it's across the industry, all the different vendors and partners that we work with. Unfortunately, we're experiencing growing pains as part of this process because we just haven't had to deal with this before, and it's been a very sharp growth recently. And so while this has been going on, like we're brainstorming, like how do we actually go about solving this? And we want to figure out like how do we do this in an iterative way without breaking too many systems along the way. And so that's just, we want to acknowledge that is an ongoing process for us, and we're scrambling here. And we'll probably have more information in follow-up meetings. But we'd love to hear like particular feedback from any community member as to how do we do this. Like what are like the things that they would suggest? How could they contribute? I think one of the biggest issues is right now that a lot of the reviewers on the Google side of things are being overwhelmed. Part of this is due to just a lack of automation in some of the systems that are in place right now, and that's definitely something that's on our radar to fix, but also just the sheer number of PRs to review. I think any way that the community, concrete suggestions would be greatly appreciated. Any way that we can get the community involved within the PR process more so. And that can be, I think, one of the easiest things to do is have the community contribute more tests and more test infrastructure. So one of the questions that we had, and it would be great to hear people's take on it, is how open would people be to volunteering cloud instances with particular hardware setups or software setups that we can include within sort of the publicly facing testing process. So when people submit PRs, that we can all see, like, are we breaking one another, and really sort of mitigate that as something that's a burden on both the reviewers as well as prevent PRs and changes from getting merged in that would break things for other people. But that said, any input that you would have would be great. Please feel free to reach out to, we have a new email address, maintainers@openxla.org. Please submit your feedback there or in one of the team members here, and we'll get it organized. But yeah, any questions about this?
Okay. So please do send us that feedback at maintainers@openxla.org. All right. Moving to the next topic, Michael.
All right, thank you. Yes, I'm Michael. I'm from the Stable HLO team, and today I'm going to be telling you a few words about this new composite op that we just added as a result of the extensibility RFC. So yeah, you might know that Stable HLO has quite a few ops, but ML and AI is a fast-moving field, and so people come up with new abstractions all the time, and we need users and consumers of Stable HLO to be able to experiment with these new operations. However, if a framework starts using a new op, some backends might not be ready for it, and so we need an ability to decompose an operation into simpler operations so that all backends will be able to process it. And we also need to have compatibility for these new operations. As you know, one of the main benefits of Stable HLO is that it provides this compatibility format that allows backward and forward compatibility. And eventually, if it turns out that a lot of people are using the same composites, they can be officially included in CHLO or Stable HLO. And that's a process that we're still thinking about how we can refine that, but that's the eventual direction that we're going in. So this is a very simple example of what a composite might look like. You can see that, we have this Stable HLO composite op. You can give it a name. We have a string here that contains the name. It takes the operands that would go into the op. And this is really modeling an operation. So it's pointing to a decomposition, which is experimental op in this case. That's just a function. But we are essentially modeling that op. So that might be like something like top K, or it could be 10 or ERF or anything like that. Next slide, please. All right, and just to call out a few specific things here, obviously the composite, the function that it's pointing to must have the same type as the composite op itself, and the name must be namespaced. This is just something that we required to try to minimize the risk of collisions between names. All right, and earlier I mentioned that some backends might want to see the composite. Maybe they have a way to accelerate it. They have a specific op on some hardware that they can leverage, and other backends might not want to see the op at all. They want to see the decomposition of simpler ops that they can handle. And to enable that, we added this pass, Stable HLO legalized composite to call, and you can see the result below. So what it does is it just turns the composite into a call to the decomposition function. And then if you actually don't want to have calls in your program, you can use the standard MLIR inliner pass to just inline all of the operations. All right, just a few additional details. So there are additional fields on the op if you need to put additional information on there. So you can have version composites, and you can also have attributes for your composite. So those, like I said, the composite is really modeling an op. And so these are kind of like the attributes for the op. So that's a dictionary. So if you had something like top K, for example, you could have an attribute that's K equals some integer. And then for legalization, by default, it will expand everything. We believe that's the correct behavior, because if you have a backend that can't handle an op and it isn't expanded, then it can't compile the program at all. So that's the default behavior. But if you do handle a specific composite, then you can say accept equals the name of the composite, and that's actually a list. So you can specify many of them, and then they won't be expanded. Of course, this is a new op that we added to stable HLO, so there's reference interpreter support for it. And as future work, I already mentioned the extensibility glide path, where we want to have a path for composites, like popular composites, to become actual ops in CHLO or stable HLO. But there's also some work to do in terms of HLO integration. Currently, XLA, like in HLO, there's not a representation for composites, but that's something that we're working on. All right, and that's all I had. I put some links here that might be useful to people. We have a link to the spec for the op, the PR that implemented the composite op, and the PR that implemented the legalization pass that I just showed you. Thank you.
Any questions? Let's open up the floor.
Yes. So one thing, maybe I missed it, but how do you reference so you define the attributes on the call, like the composite, and how do you reference the value of the attribute in the function in the function itself?
Gotcha. That's something that would need to be handled by the backend, or that would need to be sort of duplicated in the implementation of the function.
What do you mean by duplicated? Because, like, you can have, I guess, multiple composites, each calling with a different set of parameter values.
Yeah. So in that case, you could have multiple different implementations, or you could have the backend sort of refine the implementation based on the attribute value.
I see. And the other question is, like, what is this op? Like, how does this op differ from call op? Like, you can lower to a call op. So what is the difference?
Yeah, that's a great question. And we also have custom call in stable HLO, right? So there already was kind of a way to do this, but this is really a specific disciplined way of saying, I have this op, I have this abstraction, and there's a decomposition for it. And that's not really something that you could do. I mean, you could do it with custom call, but it was kind of implicit. And then I guess you could also do it with a call, but once again, it's not very specific to this use case. So this is really about modeling a specific abstraction and making sure that it's like really clear in the IR that this is this abstraction, and there's the decomposition sort of on the side.
Cool, thanks.
Thanks for the questions.
Any other questions? We've got 3 more minutes. All right. Thank you, Michael, for your contribution in the presentation.
Happy to hop in here. Talking about a few of the active RFCs. This is probably the most engagement we've ever had. I think we had 4 or 5 RFCs pop up in the span of the last month, so that's awesome to see. I'm going to skip over the first 2 because we've already heard about the Chardon RFC and the gather scatter batching. Both of them are publicly available. Once we share the slides, you can click these links to get to them easily. I think we're addressing open feedback and converging on designs at this point for those ones. Next, there is the .op algorithms. So currently .op has these precision configs that are default highest. And what those means is a bigger mystery than the semantics of gather-op. So this one is proposing some more explicit algorithms for how to actually go about handling .ops with various precisions. Next is a few MHLO features that were successful. So like there's MHLO TANOP, there's MHLO custom call with a dictionary, and there are collectives like all reduced that take multiple operands and multiple results. These are things that are valuable for various reasons. Custom call with dictionary is being hacked around in the community all over the place. Collectives are important, or the variadic operand collectives are important for horizontal scaling, and TANOP is in pretty much every other primitive op set, and it seems pretty logical to have it in ours as well. So adding those new ops that were successful, I think we're going to give quite a bit of time just to get through the queue of open RFCs. And then the last 2 are RFCs that have been open for a little while. Hybrid quantization, no major updates this month. And then the compatibility RFC for ODML, a update was recently posted to OpenXLA Discuss on the path forward there. proposing 5 years of backward 2 years of forward compatibility. Still open for discussion. It seems like most feedback has been addressed here. I think this one's probably converging in the next month. And then we will likely be rolling out this longer term compatibility and stable HLO v1.0 release, which also will hopefully, I'll be posting something about that fairly in the near future. So hopefully we'll also be approaching a v1.0 state in the next month or two. That's it.
Thank you. Any questions? Okay, gone. All right. Thank you, everybody. Let's continue to discuss. Just a quick reminder, if you did register for OpenXLA DevLab, it's happening on April 25th. I'm closing out the form today. I know you've seen a lot of emails come your way from me, but the agenda is pretty much finalized. So those of you who registered, you will see an email probably early next week with the finalized agenda for your feedback. Thank you, everybody. I'll make sure I post the slides, the recording, and the notes by end of week. So look forward to further contributions, and please reach out if you want to at the next meeting. Thanks again. Bye.
Thank you, folks.